This is the third lecture for Chapter 18, Environmental Hazards and Human Health, and we're moving on to chemical hazards. So as we can see here, there's a couple different categories. I believe there's a total of 6 that we'll mention here. But we have these different definitions that you can look at here as far as what some of these chemical hazards are. Mutagens can cause mutations in DNA within a cell. Teratogens are something that can cause deformations or other impairments on the embryo, the developing fetus, and carcinogens are things that can cause cancer. So just to mention a couple teratogens, the first one here listed is phthalo or thalidomide. That is something that was given to women in the 50s and 60s or up until the 60s that was supposed to treat a morning sickness and had the effect of very much limiting the growth of limbs, both arms and legs. There's a video that goes along with it, but I didn't want to show it. It was something that was stopped, and of course was a terrible scenario for many people, both on the child having to live with this issue, and of course on the mother that was just trying to limit the discomforts. So yeah, medicine, and we'll talk more about the idea of why did they prescribe that a little bit later. The other one is alcohol. That is obviously we've all heard about that. Fetal alcohol syndrome is it's a problem, and mothers of course should not drink alcohol, whether it's red wine or not. So here's another list of 3 more. So we said there were 6, and here's the other 3. Neurotoxins, self-explanatory. Allergens, many of us have this issue, which is not really a true problem, but it's something that the body reacts to it like it is a problem, and you have the results anyways. And endocrine disruptors are some things that disrupt. They can go a couple things. They can mimic, they can disrupt, or they can just have an effect as far as plugging in and having some other effect to a receptor and giving the body an effect that it normally would not have if this chemical was not in the body. We'll look more at that one a little bit later. So as far as where we can have these effects in the body, one of the things, of course, your immune system is how you fight disease and stay healthy. Your nervous system as far as how you function, and the endocrine system we already mentioned. So this is a little diagram as far as, a very simple diagram that, if the cell is supposed to take in these circular type receptors as far as a chemical lock and key scenario would go, normally that's what's supposed to happen, but you can have some things coming in. For example, an estrogen-like chemical, which I believe would be like DDT, could come in and mimic those chemicals, and therefore your normal chemicals aren't able to attach. So you have this unwanted effect. And then you could also have a scenario where something is blocking, and it's not necessarily having an effect itself, but it is blocking the receptors, so your normal chemicals cannot get in. This is all really interesting. If you take psychology or APES psychology, you'll probably talk about that quite a bit more. So here's a couple other chemicals which have some problems for the body. And some of these you've heard about or are familiar with. And then some other ones maybe not so much. PCBs were something that was used in industry as like an insulator. But of course these are listed as a carcinogen, and we no longer can use those. And there's something else that goes along with these. PCBs, a lot of chlorinated organics. The problem with these things is if you go to incinerate them. It's like, all right, we don't want these PCBs around, and we're going to incinerate them, and we don't do it properly. What you can produce are things called dioxins, and this is a very can't think of the right words, a cancer-causing agent, so I'll just leave it at that. But it's interesting as people hear this, and maybe you've heard it before, dioxins. Nobody's ever made these purposely. So it's not a substance that was on the market like PCBs. There was a use for these things. Dioxins, nobody intentionally tried to make these things. It's a byproduct in the incineration process, and it can get in the air, but it is something that certainly can cause cancer very easily. And you have the other ones listed here as well. Another one we'll mention later on is atrazine. Usually you're looking for frogs and such that aren't able to mature So atrazine is something that I believe was eliminated in fertilizers. I'm not sure that's still out there or not. I'll look that up. And the other ones you've heard of. Okay, moving along. And just looking as far as our exposure, how do these things happen to us? Where do they come from? So we have all these different listings here based upon, where you live, your exposure to certain things, your lifestyle, your culture. All of these things will come into play as far as helping to determine your personal health. Okay, a couple good concepts that we're going to talk about here is something called the LD50 and the ED50. LD50 is just a measurement for any chemical. You could even look at water, I guess, if you wanted to. But how and when will it kill off half the population? Very weird setup here, but this is how it goes, is, talk about it for aspirin. So if you had lab rats and you're feeding them aspirin, at what dosage do half the rats or mice die off? And looking at that, so, okay, well, that is the LD50, and then we can do some manipulations based on that data. The ED50 is not looking for death, it's just looking for an effect. What happens, and now I can talk about that. So if I had some threshold value that I'm looking at saying, this is when the effect took place, I can look at the data based upon that. And okay. So something else we'll mention here is based on these values. So I've determined the LD50 when I kill off 50% of the population. If I'm looking at as far as exposure for animals, whether it's livestock or whatever else we may be talking about, we will take that LD50 and divide it by 10. That's important for you to know, that this is the value that they can be exposed to. I'm not sure why they come up with that or not. But then we use that exact same number based on the exposure to the rats and mice, and we divide it by 1,000 for humans to say, okay, this is the value that humans can be exposed to it. Part of it is our longevity. We live longer than most animals, but then the other part is, of course, because we're humans and we care more about humans. The other one we need to know about, and I think the only place you're going to talk about it is right here in the lecture, is a threshold dose. Threshold dose is, think about aspirin. If you took 1/100th of an aspirin, it would probably have no effect at all on you. So the aspirin that you take is very deliberate. That's the amount you're supposed to take to give you the effect that you want. So that's a threshold dose. So for example, it says take 2 tablets. So you take 2 tablets. And that gives you the effect right here. I'm just going to make a mark and say that is a threshold dose to give you the effect of relieving your headache. Now, what it also points out is there's no negative effects documented. So we're okay. We get rid of the headache and nothing bad happens to your liver or kidneys or whatever. If you start exceeding that value, well, your headache's going to go away, but now you're also going to have some negative effects based upon that. So that is called a threshold dose. Moving along, some things that determine the concentration of the dose. So how does that come about? When are we going to start having some negative effects, and what goes into determining the concentration? Well, one of them is how long does this stuff hang out in the environment? So persistence, that's a vocab word. So if this chemical stays in the environment for 10, 20 years, then that's going to have an effect on the concentration of your exposure. The other ones would be the solubility. Is it water soluble or is it fat soluble? Water soluble things we typically will shed, not always, but fat soluble is typically going to be stored in the body. And if it's stored in the body, then it has the ability to bioaccumulate. And if it bioaccumulates, if something else is eating that individual, say small fish, big fish, larger fish, and then birds, then it has the ability to biomagnify. Think about the fat. So all these things have fats in them. It's going to biomagnify up the food chain, and eventually, potentially, you could eat it. And that, of course, would have a larger negative effect. But none of this really has anything to do with the LD50 of the compound. That's kind of a different conversation. So we're talking about how does it, what's affecting the concentration within the environment and onto you. Okay, good place to take a break, and we'll pick up the fourth and possibly the final lecture after this one.